Now let's take a more formalistic way of introducing interest rates. We saw already in the pricing formula that we are using interest rates. In this case, we are using for the 4-year bond, we were looking at the 4th-year spot rate. But let's introduce a different term, also looking in the same formula, for the zero coupon bond. So let's say instead of writing R4 here, which is the 4-year rate, if I would write P is equal 100 divided by 1 plus y to the power of 4, right? So then, well, I mean, that would be the same way of finding out what y is, which is exactly the same value as we already figured out for R4, which is 6.4%, right? But now, y is something we call yield to maturity, which has got not to do with the bond market, so it doesn't have a time index. But actually, if you notice here, it has got an index which goes with the bond. So the yield to maturity is the internal rate of return, the average rate of return of the bond, right? So in this case, if you were looking into the zero coupon bond, then we have essentially that this R4 was also equal to y, right? And that's because we are looking into for a 4-year zero coupon bond, right? So for a 4-year zero coupon bond, the internal rate of return, or the yield to maturity of that one, has to correspond to the 4-year spot rate. But now, if I'm looking at this example, so rather than writing R1 to R4, if I would write, this is back to our bullet bond, right? So this is a 4-year bullet bond. 4-year bullet bond. And, well, one way of looking at this is discounting the cash flow with the spot rates or the interest rates of that particular bond market. We'll get back to where what the bond market is. But another way of looking into this would be saying, well, what is the internal rate of return for this particular bond? Let's forget for a second that there is such a thing as a bond market and it's got some interest rates attached to it. I can look at this particular bond in an isolated manner, and then I'll decide what is the internal rate of return for this particular bond. So notice now is the same y, which goes through, plus 5, 1 plus y to the power of 3, plus 105, 1 plus y to the power of 4, right? Okay, so the first question here is there a unique answer for this one? Yeah? And is it easy to find? Is there an analytical solution to isolate y? So already now we are getting into kind of trouble, right? But I mean, you probably, if you had a course in numerical math, probably at the 1st or 2nd semester at this university or at similar technical universities, you will work with some numerical routines to be able to find a value for y, and those would amount to some way of essentially guessing a value for y and then trying to converge towards a value which gives you the real number. Now, we don't want to do this exercise, but this is essentially to say that y in this case, or yield to maturity, the way you have to understand it is the average rate of return for that particular cash flow that we are looking at, right? So this is your average return for this particular bond. And in this case, obviously, y is not equal R4 anymore. That was only the case if you had a zero coupon bond, right? So this is yield to maturity. And then we get back to what actually we started out with, which is the R's. So the Y is called yield to maturity. Y is yield to maturity. And then we have the R, RT. These are the spot rates. So the spot rates, they do not belong to one particular bond, but they belong to a bond market. Now, what is essentially a bond market? Anybody can give a guess? What is, when I say a bond market, what do I actually mean with that? Is there one bond market, or are there many bond markets? And what does kind of specify that we have a bond market here? Can you think of any examples of real life bond markets out there? Yeah. Right. Very good. So government bonds is an example of one bond market. So I'll just write it over here. So we have government bonds. So examples of bond markets. Government bonds is a very good example. That's one way for the governments to raise money. I mean, governments, again, they can raise money via taxes, but they can also raise money via issuing bonds, right? Essentially, they lend some money to themselves or borrow it from their citizens, right? Or from foreign countries, right? So government bonds is one example. Any other examples of what bond markets we have? Yeah. Sorry? Company bonds, yeah. This is corporate bonds or company bonds. Corporate bonds, corporate bond markets. And normally then you have, within that, you have different classes of corporate bonds. So some are kind of more risky, some are less risky. And then when you're talking about a particular bond market, normally you want the total market to be homogeneous. So you want to have a market of, let's say, a high yield corporate bonds, and then you have like high risk or low yield, or high risk and high yield, or it could be low risk and low yield corporate bonds. So it could be that then put into different corporate bonds markets. When you talk about government bonds, it goes by the country. So you can have the Danish bond market, then you have the German, the Greece, or the American. So each country has its own bond market. So there is not one government bond market, but there's countrywide bond markets. Any other examples of bond markets? I mentioned something with these annuities and mortgage-backed securities. So that's the, sorry? The housing, yeah, and that is normally, they say the mortgage-backed bonds, where mortgage essentially is got to do with the property. So it's bonds which are backed by some properties, so mortgage-backed bonds. So that's got a particular market. So in Denmark, we have a very versatile and huge mortgage-backed market. Germany has the same. Some other countries don't have that big of a mortgage-backed market, but there are a few countries, especially in Europe, where we have a huge mortgage-backed market. Right? Maybe a final example. Have you heard of the term municipal bonds? So it's bonds which are issued by local governments. So a bit like the government bonds, but it's local governments like municipalities. So each and every one of them, they constitute a bond market. And for each and every one of them, you have to have a specific set of spot rates. So the spot rates for the Danish government market are different from the spot rates for one thing, from the Greek government bonds, or for that matter, for the Danish corporate bonds, or the Danish mortgage-backed securities, or the municipal ones. So when you talk about bond markets, it's not one market, but there could be many markets, and for each of them, you will have a set of spot rates that would be defined by essentially observing the prices of as many bonds as you can get your hands on that particular market, and then make a system of equations like this with as many bonds as possible, and then try to estimate the R's as best as you possibly can. And that's the purpose of what we're going to do here after the break. Right, so that was the R's, they are the spot rates. And if you draw spot rates as a function of maturity, so this is maturity or time, and these are the spot rates, normally you get a shape which looks like this. So that essentially means that the higher the maturity, like if you are looking at a 10-year spot rate, the 10-year spot rate is higher than the 1-year spot rate, right? And the 30-year spot rate is higher than the 10-year spot rate. But as we tend to go towards longer and longer maturities, then the margin by which the interest rate increase gets smaller and smaller. So that normally, this is the normal shape of what we call a term structure of interest rates, or it's also called a yield curve, by the way. So you have a term structure of interest rates or a yield curve, and that's in normal cases and normal times, it looks something like this. Now, can somebody tell me why is it that this is normal? This is what we'd expect from a spot rate. We would expect that the higher the maturity, the higher the spot rate should be. The risk increases with time. That's right. The higher you go into the future, there is a risk that you never get your money back. That's why you require, as the lender, to get actually some higher interest on your bond. Yes. Yeah, inflation. That's also that's a good question. So at least, or it's the risk that inflation is going to increase, right? Because if you knew that inflation was the same, so there was that. But I mean, so again, it goes back to the question of risk. So you have the risk of defaults, that you're never going to get your money back, or the risk that the interest rates are going to go up. So the more you wait, so you want to get a higher interest rate on your money. So that kind of makes good sense that the graph should look like this. Now we'll see that this is see next week that this is not necessarily the case. Sometimes in the markets you will observe yield curves or term structure of interest rates which are either flat or even inverse. So those are the yield curves that we call non-normal, and we'll have a discussion of why is it, how, under what conditions such curves can actually be seen. But most of the time, if you do an empirical study for these different kind of bond markets over time, most of the time you will see a structure which looks something like that. All right. One final comment about when you're talking about interest rates. There's also, so we talked about yield to maturities. We talked about spot rates, and spot rates, they are spanning term structure of interest rates or yield curves. There's another term I want you to learn, and that is forward rate. So in the spot rate is the rate from today up to some point in the future. Now, a forward rate is essentially a spot rate from some time in the future to some time further in the future, right? So what we have here is that, let's say, if I'm discounting, in this case, 1 krona forward by the spot rate, which is called R tau, right? So I can just say 1 plus R tau to the power of tau. Let's say tau was 10, right? So this is the 10-year spot rate. So 1 plus the 10-year spot rate to the power of 10. That would be discounting 1 krona forward 10 years with a 10-year spot rate, right? So instead of doing it directly, let's say what I did was that I say, all right, I'll first go to the time t, which is smaller than tau. So let's say t is 8. So I discount then 1 krona 8 years forward, right? That's 1 plus R8 to the power of 8. And then for the remaining 2 years, I'll take this amount and I discount it forward another 2 years, which is, in this case, 10 minus 8, which would be to the power of 2 here, right? Then I need something here, which is essentially a forward rate. So ft tau then is the forward rate from time t to time tau. So this is essentially the definition of a forward rate. It's a spot rate from sometime in the future to sometime further in the future. And then if I want to isolate ft tau, here is how it looks like. I'm not going to go through all the isolation that you would do for ft tau. You can easily do that, and you can come down to this, which is the formula for a forward rate based on a spot rate. So from a spot rates, you can go to forward rates. Now, there's one thing that you can do this exercise and show that this should be the formula for forward rate. Another thing is that if you're observing in financial markets, in bond markets, and you want to, based on the RT, essentially you want to guess what the future rates are going to be, because I mean that just sounds way too convenient, right? So by only looking into the RTs, which are the spot rates, those are the ones I can observe today, right? So I can go to a bond market where I can see the price of this bond is 98 for a 4-year bond, bullet bond, and then let's say I have a 5-year bond, a 10-year bond, a 15-year bond. So I have all these sets of bonds, and based on that, I decide what is R1 to R10, let's say, up to 10 years, right? I can do that. I can do that today, and from this formula, I'm telling you that then I can actually specifically isolate what is then the 1-year rate in 9 years, right? So what is the rate from year 9 to year 10? Well, this is kind of, in a way, is it the implied forward rates which are in that particular bond market. But those implied forward rates essentially don't have any prediction power when many people have tried, many researchers have tried to do empirical work to see whether this simple formula or some extensions to that could help you from how people essentially price. We collectively price based on our best guesses in a very liquid market what the prices of such bonds should be, because implied in that we are indirectly saying we have some expectations to how the rates are going to move in the future. But it shows again and again to see if those expectations that we had, which were implied in the prices that we were willing to offer for these bonds, those essentially don't have any prediction power. So the interest rates, again and again, they won't be what these forward rates are going to say. So even though this is kind of a convenient formula, and sometimes you will be using it for different purposes, we'll see in a minute how it would be used in the bootstrapping setup. But essentially, you shouldn't be using forward rates for trying to have a guess at what the future rates are going to look like. All right, so that was the second lecture for today. Let's take 10 minutes break, 13 minutes break. We start 5 minutes to 2.